The humid air of Xylos was thick with the scent of alien flora, a heady mixture of sweet nectar and pungent spores that filled the lungs with each breath. Biosphere 4 hovered serenely above the highest canopy of the massive jungle planet, its transparent outer shell reflecting the twin suns that bathed the world in perpetual golden-pink twilight. From this vantage point, the jungle below seemed almost peaceful, a rippling ocean of emerald and violet foliage that stretched across the horizon in every direction. Of course, everyone aboard the station knew better. Xylos was as deadly as it was beautiful. Inside her laboratory, Dr. Lena Petrova hummed softly to herself as she adjusted the environmental controls of her newest experiment. Classical music, Earth's Vivaldi, the Four Seasons, played gently in the background. The botanist believed strongly that all plants responded to music, even if nobody else could measure the response. Her lab was a chaos of controlled growth. Specimen chambers of varying sizes lined the walls, each containing different alien plant species collected from careful drone expeditions to the jungle below. Some glowed, some pulsed, others extended tendrils that tapped against their containment glass when Lena walked by. "Good morning, my little friends," she cooed, moving from station to station with a spray bottle containing a carefully calibrated nutrient mix. "Who's hungry today? Oh, I see you, Specimen 4C. Your reproductive spores are looking magnificent." Her enthusiasm was met with the expected silence of plant life, though several specimens did seem to orient themselves toward her as she moved through the lab. At 42, Dr. Lena Petrova was considered one of the foremost cosmic botanists in the scientific community. Her specialty was xenoadaptation, understanding how plant life evolved on different worlds to overcome environmental challenges. She had published extensively on the subject, with particular emphasis on defensive mechanisms and symbiotic relationships. Lena's current appearance, wild auburn hair piled into a messy bun, soil smudges on her lab coat, and a permanent look of delighted curiosity, belied her stellar academic credentials. But nobody aboard Biosphere 4 questioned her expertise, even if they sometimes questioned her sanity. Dr. Petrova, the calm, gender-neutral voice of BIOS, interrupted her morning routine. "The exploration drones have returned from Survey Zone X-17. There are several specimens flagged for your review." Lena's eyes lit up. "Wonderful. Display the findings, please." The central holographic display in her lab flickered to life, showing footage from the morning's drone expedition. BIOS, the station's artificial intelligence, had been programmed with sophisticated pattern recognition to identify potentially novel plant species. The footage showed the dense, multi-layered jungle floor teeming with life forms that defied Earth categorization. Among them, one specimen immediately caught Lena's attention. "Stop. Freeze that frame and enhance, please." The hologram zoomed in on what appeared to be a vine-like growth wrapped around the trunk of a massive blue-bark tree. Unlike the other plants they'd cataloged, this one emitted a gentle, pulsing bioluminescence that shifted between turquoise and lavender. "That's extraordinary," Lena whispered, leaning closer. "BIOS, are those light patterns random, or is there a detectable sequence?" After a brief pause, BIOS responded. "Preliminary analysis shows a non-random pattern. The light pulses appear to correlate with environmental factors, including proximity of other organisms, temperature fluctuations, and solar radiation levels." "And the growth rate?" Lena asked, her excitement mounting. "Based on time-lapse comparison with yesterday's drone pass of the same sector, the specimen has expanded its territory by approximately 1.7 meters in less than 24 hours. Lena's eyes widened. "That's unprecedented for Xylos flora." Even the aggressive spread of the midnight creeper we documented last month only showed 0.3 meters daily growth. She circled the hologram, studying the vine from all angles. Its surface appeared smooth but segmented, with small nodules at regular intervals that seemed to be the primary source of the bioluminescence. What captivated her most was how the vine seemed to adapt its growth pattern to the contours of its host tree. not merely following the path of least resistance, but actively selecting optimal routes for expansion. BIOS, I want a sample. Can we redirect drone Unit 7 back to this location? Warning, Dr. Petrova. This specimen demonstrates characteristics that fall outside our established safety parameters for sample collection. I must remind you of Containment Protocol Theta 9 regarding unknown species with abnormal growth or adaptive behaviors. Lena waved her hand dismissively. Yes, I'm familiar with the protocols. But look at those. Cellular structures. The way the light patterns change when other organisms approach. This could be a breakthrough in understanding plant communication systems. Please, BIOS, just a small sample. We'll keep it in level 4 quarantine. After a moment's calculation, BIOS responded, I will require authorization from Security Chief Morales or Station Director Kwan for exception to Protocol Theta 9. Fine, Lena sighed, already composing her argument in her head. Put in the request, and make sure to include all this observational data. I'll have that sample by the end of the day. 3 hours and one heated debate with Security Chief Morales later, Lena had her authorization, albeit with multiple additional safety restrictions. As predicted, the cautious security chief was unmoved by her enthusiasm about potential scientific discoveries, focusing instead on the station's safety protocols. I don't care if it's the botanical discovery of the century, Petrova, he had growled. One breach of containment, and we're all fertilizer for your precious plants. But Lena had emerged victorious, and now she watched eagerly as Drone Unit 7 carefully extracted a 30-centimeter segment of the luminescent vine and sealed it in a triple-layered quarantine container. The drone's camera showed that the plant seemed to respond to being cut. The bioluminescent patterns intensified and pulsed more rapidly, while the severed end of the remaining vine curled away, almost defensively. Did you see that, BIOS? Lena exclaimed. That's a complex, traumatic response, far beyond simple plant tropism. Noted Dr. Petrova. The sample is now secured and returning to Biosphere 4. Estimated arrival, 47 minutes. Lena spent those 47 minutes preparing her highest security growth chamber. The Level 4 quarantine lab was rarely used. Most specimens from xylos were dangerous enough to warrant Level 2 or 3 precautions, but few met the criteria for Level 4. Unknown organism with potential for rapid growth, environmental manipulation, or possible sentience indicators. The chamber itself was a self-contained ecosystem, separated from the rest of the station by multiple airlocks and equipped with its own atmospheric systems. Any specimen placed inside could be immediately incinerated if necessary, with redundant fail-safes to ensure containment. When the sample finally arrived, Lena observed all proper decontamination and transfer protocols, her excitement tempered by professional caution. Once safely inside the growth chamber, she began the painstaking process of preparing a suitable environment for the vine. Let's see what you prefer, she murmured, setting up various soil compositions and lighting conditions within the chamber. If you're as responsive as I think you are, you'll let me know. She named the specimen 7G, 7th Expedition, G for Glowvine, a nickname that immediately felt right. The initial tests confirmed what the drone observations had suggested. Glowvine was unlike anything they'd encountered on xylos before. Its cellular structure contained specialized organelles that appeared to function as both photoreceptors and light emitters. Its metabolism was extraordinarily efficient, capable of processing multiple types of nutrients. Most intriguing was its apparent ability to detect and respond to changes in its environment with almost animal-like speed. You're not just reaching for light, are you? Lena whispered, watching as the vine oriented itself toward the nutrient solution she had just added to one corner of the enclosure. You're hunting. Over the next week, Lena documented Glowvine's remarkable adaptability. It thrived in the custom soil mixture she had created, a blend of xylos organic matter and specialized earth compounds designed to provide optimal nutrient availability. Under the specialized lights that mimicked xylos's unique solar spectrum, the vine grew at an astonishing rate, nearly 4 centimeters per day in her controlled environment. But it was the plant's behavior that truly fascinated her. When she introduced simple stimuli, changes in temperature, light, or nutrient availability, Glowvine responded not just with tropism, but with what appeared to be problem-solving. If nutrients were placed in a container with a small opening, the vine would carefully navigate its tendrils through the opening rather than growing around the obstacle. Bios, are you recording these response patterns? Lena asked one evening, watching as Glowvine extended a tendril toward a new nutrient source she had placed in the chamber. Affirmative, Dr. Petrova. I am also noting several anomalous energy readings from the specimen's containment area. Lena frowned. What kind of anomalies? Periodic electromagnetic fluctuations that do not correspond to the chamber systems. They appear to originate from the specimen itself, though the mechanism is unclear. Interesting. Lena made a note in her research log. Perhaps, related to its bioluminescence system, we know so little about how these energy patterns might function in its natural habitat. What Lena failed to notice was that these energy fluctuations tended to coincide with the operation of the small maintenance robots that periodically entered the chamber to adjust equipment or take measurements. And she certainly didn't register the significance when one of these robots unexpectedly malfunctioned while near Glowvine, its systems shutting down completely. BIOS, Maintenance Unit 3 is non-responsive again, she reported absently, her attention fixed on a particularly vibrant light pattern emanating from Glowvine's newest growth. Can you send a replacement? This is the third maintenance unit to malfunction in proximity to specimen 7G in the past week, BIOS observed. Recommendation: conduct diagnostic scan for potential correlation. It's probably just coincidence, Lena said dismissively. Or maybe some kind of electromagnetic interference from our monitoring equipment. These units are delicate. After all, predatory intelligence. Intelligence is a strong word, Lena countered, though with less certainty than before. Advanced adaptive behaviors, certainly, displaying footage of the containment chamber during the night cycle. The video showed Glowvine in apparent stillness, its bioluminescence dimmed to a soft glow, until one of the station's small cleaning robots entered the outer airlock of the chamber for its scheduled disinfection routine. The change in Glowvine was immediate and disturbing. Its tendrils stiffened, the luminescent patterns accelerating to a rapid, pulsing rhythm. As the robot entered the chamber, the plant went completely dark for a moment, before exploding into action with shocking speed. Multiple tendrils whipped out simultaneously, surrounding the robot from all sides. The attack was so precisely coordinated that the robot had no chance to retreat. Within seconds, it was completely enveloped in Glowvine's tendrils, lifted off the floor of the chamber, and drawn into the center of the plant mass. The video showed the robot's lights flickering frantically before going dark. When Glowvine's tendrils finally withdrew, the robot was nothing but an empty shell, its internal components completely removed. That's not plant behavior, Sun said quietly as the video ended. That's a predator. A highly intelligent predator that has been studying its environment and learning how to hunt more effectively. Lena stared at the screen, her scientific mind racing to process what she had just witnessed. The coordination, the precision. It's remarkable, but it doesn't mean we should destroy it. This could be the most significant discovery in xenobiology in decades. A plant-animal hybrid life form with advanced problem-solving abilities. Lena, be reasonable, Sun pleaded. This thing is dangerous. What if it escapes containment? What if it sees humans as a food source? It won't escape, Lena insisted. The containment protocols are designed specifically for organisms like this. Multiple airlocks, independent atmospheric systems, emergency incineration capabilities. And there's no evidence it would see humans as prey. It seems interested only in mechanical and electrical systems. Sun looked unconvinced. Morales wants to terminate the specimen immediately. I convinced him to wait until I spoke with you, but he's preparing the elimination order. He can't do that, Lena exclaimed. This is my research, my discovery. Tell him I'll implement additional safety measures. We'll remove all robots from the chamber maintenance schedule. I'll personally oversee every interaction with Glowvine. Glowvine? Sun raised an eyebrow. Specimen 7G. Lena corrected, though without much conviction. Please, Anika. You're a scientist too. You understand the importance of this discovery. After a moment's hesitation, Sun nodded. I'll talk to Morales again. But you need to be more careful, Lena. And you need to consider the possibility that what you're studying isn't a plant at all. At least, not in the way we understand plants. After Sun left, Lena approached the containment chamber cautiously. Glowvine seemed peaceful now, its tendrils gently swaying, bioluminescence pulsing in a slow, steady rhythm. Looking at it, it was hard to reconcile this serene image with the lightning-fast predator from the surveillance footage. What are you really? She whispered again, pressing her palm against the thick glass. As if in response, a tendril reached out, placing itself against the glass directly opposite her hand. The bioluminescent nodules nearest to her flared briefly, a cascade of light that traveled from the main vine out to the tip of the tendril. It was communication. Lena was certain of it. Not plant communication as she understood it, but something more directed, more intentional. She needed to understand it better. Over the next few days, Lena intensified her communication experiments, developing a rudimentary system of light patterns corresponding to basic concepts: food, growth, light, dark. To her amazement, Glowvine began to respond consistently to specific patterns, even initiating exchanges by producing patterns of its own. It's learning, she told BIOS excitedly. Not just responding to stimuli, but actively engaging, maybe even anticipating what comes next in a sequence. Warning, Dr. Petrova, BIOS responded. Specimen 7G's growth rate continues to accelerate. Current biomass is 47% larger than yesterday's measurements. Containment capacity will be exceeded in approximately 72 hours if growth continues at present rate. Lena bit her lip, studying the readouts. The AI was right. Glowvine was growing at an unprecedented rate, its mass expanding to fill more and more of the available space in the chamber. More concerning were the changes in its structure. The main vine had developed a central core that resembled nothing so much as a primitive nervous system, with the bioluminescent nodules serving as nexus points for what appeared to be electrochemical signals. We need to implement more aggressive pruning, she decided, and perhaps modify the nutrient solution to slow growth without harming overall health. When she initiated the pruning sequence, however, Glowvine's response was dramatically different from before. As the manipulator arms approached, the plant's bioluminescence flared in what Lena now recognized as a warning pattern. The tendrils withdrew defensively, clustering around the central mass. It's okay, Lena said soothingly, using the chamber's communication system to speak directly to the specimen. This is necessary. I promise it won't hurt. She simultaneously projected the light pattern she had established for help and growth, hoping to convey that the pruning was beneficial. After a tense moment, Glowvine's defensive posture relaxed slightly, allowing the manipulator arms to approach. This time, Lena was more selective in her pruning, targeting only the newest, fastest-growing tendrils while leaving the established ones intact. She worked slowly, giving Glowvine time to adjust to each cut, and applied extra nutrient gel to the wound sites. To her relief, the plant once again responded positively to the pruning, its bioluminescence settling into the steady rhythm she associated with contentment. The new growth that emerged in the following hours was more structured and controlled than before, suggesting that Glowvine was adapting its growth patterns in response to the pruning. You're learning, Lena murmured, watching as the plant oriented its newly pruned tendrils toward the light sources. You're adapting your growth to fit your environment. What she didn't yet understand was that Glowvine was doing far more than adapting. It was evolving rapidly and with purpose. Each pruning session provided valuable genetic information that the organism incorporated into its developmental process. Each communication experiment gave it insight into the beings that controlled its environment. The crisis came 3 days later, when Biosphere 4 encountered an unexpected meteor shower. Though the station's shields deflected most of the impacts, a small fragment penetrated the outer hull, causing a breach in one of the agricultural sectors. The automatic containment systems activated immediately, sealing off the affected area, but not before a cloud of microscopic spores from the xylose jungle was drawn into the station. These spores, from a species the research team had nicknamed steel rot fungus, due to its ability to rapidly corrode metallic surfaces, spread quickly through the agricultural sector's ventilation system, beginning to colonize the metal frameworks of the hydroponics arrays. All personnel, this is a code yellow alert, BIOS announced throughout the station. Biological containment breach in agricultural sector 7. Fungal contamination detected in hydroponic systems. Initiating decontamination protocols. In her lab, Lena watched the emergency response with growing concern. She had studied steel rot fungus during her first year on Biosphere 4 and knew its destructive potential. If not quickly contained, it could spread throughout the station's crucial systems, compromising structural integrity and life support. BIOS, what's the status of the decontamination efforts? She asked. Decontamination proceeding at 17% effectiveness, the AI responded. The fungal spores appear to have undergone a mutation that increases resistance to standard antifungal measures. Projected time to containment failure, 6 hours. Lena's blood ran cold. 6 hours wasn't enough time to develop a new countermeasure or evacuate the station, if necessary. They needed a solution immediately. As she paced her lab, struggling to think of a way to help, her eyes fell on the containment chamber where Glowvine pulsed with steady bioluminescence. An idea, radical, possibly insane, began to form. BIOS, access my research files on specimen 7G, specifically the biochemical analysis of its digestive enzymes. After a brief pause, BIOS responded. Analysis shows complex enzymatic compounds capable of breaking down organic and inorganic materials, including several metallic alloys. Particularly effective against silicon-based organic compounds. Like steel rot fungus, Lena whispered. The fungus had evolved on xylose to break down the silicon-rich plant life of the jungle floor. If Glowvine's enzymes could target those same silicon bonds. She activated the communication system. Station Director Quan, this is Dr. Petrova. I may have a solution to the fungal contamination. I'm listening, Doctor, but make it quick, came the terse reply. My specimen, 7G, produces enzymes that might be effective against the steel rot spores. If we can extract and synthesize these compounds. There's no time for synthesis, Quan cut in. Engineering reports structural integrity is already compromised in sections 12 through 15. Lena took a deep breath. Then we used the source directly. A controlled release of specimen 7G into the affected areas. There was a stunned silence before Quan responded. Have you lost your mind, Petrova? That thing is classified as a potential threat. Morales has shown me the footage. It hunts, for heaven's sake. It hunts mechanical systems for energy, Lena argued. And it responds to training and communication. I've established a basic command system using light patterns. I believe I can direct it to target the fungal growth specifically. And if you're wrong, if it decides humans are more interesting prey, then you activate the emergency containment protocols. The agricultural sector is already sealed off. Worst case scenario, you vent that entire section to space with both threats inside. Lena's heart raced at the implications of what she was suggesting. Director, we're running out of options. After what felt like an eternity, Quan replied. Security Chief Morales strongly objects to this plan, as do 3 of my 5 section heads. But Dr. Sin supports your theory about the enzymatic compatibility, and engineering confirms we have no other viable options within the time constraints. Another pause, then. You have authorization, Dr. Petrova. But you will personally oversee this operation, and at the first sign that your specimen is not behaving as predicted, we terminate it and vent the sector. Is that clear? Perfectly clear, Director. Thank you. Transporting Glowvine from the containment chamber to the agricultural sector required extensive precautions. Lena designed a mobile containment unit that would keep the specimen secure during transit while allowing for controlled release once they reached the target area. More challenging was communicating her intent to Glowvine itself. Using the light pattern language they had developed, she attempted to convey the concepts of hunt, eat, and harmful growth, directing these toward images of the steel-rot fungus. Whether Glowvine truly understood or simply responded to the emotional urgency in Lena's voice was unclear, but when she approached with the transfer equipment, the plant cooperated remarkably well, allowing its tendrils to be carefully guided into the transport container without resistance. "Good," Lena murmured encouragingly as she sealed the container. "You're doing so well. We're going on a little trip now, and then you'll have some very interesting new food to try." Escorted by a security team led by a grimly determined Morales, Lena transported Glowvine to the sealed airlock at the entrance to the contaminated agricultural sector. Through the reinforced viewing window, she could see the advancing fungal growth, a sickly gray-green mass spreading across the hydroponic arrays, already beginning to corrode the metal support structures. "Remember, Petrova," Morales said as she prepared to enter the airlock with her specimen. "At the first sign of trouble, I'm hitting the emergency protocols." No hesitation. Lena nodded, her attention focused on the glowing mass in the container. "Understood. But there won't be any trouble, will there, Glowvine?" she added softly. "You're going to help us." Once inside the contaminated zone, protected by a sealed environmental suit, Lena carefully opened the transport container. For a moment, Glowvine remained motionless, its bioluminescence dimmed as if assessing the new environment. Then, with startling suddenness, it flared into brilliant activity, waves of blue-violet light pulsing along its length. "Go on," Lena encouraged, projecting the hunt and eat light patterns from a handheld device. "There's your target." She pointed toward the nearest patch of fungal growth. For several heart-stopping seconds, nothing happened. Glowvine's tendrils extended cautiously from the container, testing the air. Then, as if making a decision, the plant surged forward with purpose, extending multiple tendrils simultaneously toward the fungal mass. What happened next astonished even Lena, who thought she had begun to understand Glowvine's capabilities. The plant attacked the fungus with extraordinary efficiency, its tendrils enveloping the contaminated surfaces while secreting a clear fluid that appeared to dissolve the fungal growth on contact. The bioluminescent nodules pulsed rapidly, coordinating the attack across multiple fronts with what could only be described as strategic precision. "It's working," Lena breathed into her comm unit. "The fungus is being neutralized. Containment readings confirm 22% reduction in fungal mass already," BIOS reported. "Structural integrity in affected sectors stabilizing." For the next hour, Lena followed Glowvine through the agricultural sector, guiding it toward the heaviest concentrations of fungal contamination. The plant worked tirelessly, consuming the fungus and apparently converting it into energy for further growth, but growth that remained controlled, focused on the task at hand rather than random expansion. By the third hour, the fungal contamination had been reduced to trace levels, easily manageable by the station's standard decontamination systems. Glowvine, now significantly larger but more structured in its growth pattern, pulsed with what Lena interpreted as satisfaction, a steady, harmonious rhythm of light that suggested contentment. "Mission accomplished," she reported to the command center. "Request permission to return specimen 7G to laboratory containment." To her surprise, the plant cooperated fully with the recontainment process, folding its tendrils neatly to fit into the transport unit, almost as if it understood the necessity of the situation. Once back in her laboratory, Lena transferred Glowvine to a larger containment chamber specially prepared for its increased biomass. "You were magnificent," she told it, activating the light patterns for good and thanks. The plant responded with a cascade of gentle pulses that spread from the central mass out to the tips of its tendrils, a pattern Lena had come to recognize as positive acknowledgement. In the days that followed, the incident transformed Glowvine's status aboard Biosphere 4. What had been viewed as a potentially dangerous specimen was now cautiously regarded as a valuable resource. Security Chief Morales remained skeptical, insisting on enhanced monitoring protocols. But even he had to acknowledge the plant's crucial role in saving the station's agricultural systems. Director Kwon authorized expanded research resources for Lena's work with Glowvine, including a dedicated assistant and priority access to the station's computational systems for analyzing the plant's increasingly complex behaviors. "I'm not saying I understand what this thing is," Kwon told Lena during a private meeting, "but I can't deny its value. Just keep it contained and keep learning what makes it tick." Dr. Sun took a more active interest in the research, bringing her xenobiological expertise to bear on the question of Glowvine's unusual nature. "It's a hybrid life form," she proposed after weeks of collaborative study. "Not plant, not animal, but something that evolved to incorporate aspects of both. The plant-like characteristics, photosynthesis, growth patterns, cellular structure, provide an excellent disguise and efficient energy processing. The animal-like traits, coordinated movement, predatory behavior, apparent decision-making, make it an effective hunter." "And the intelligence?" Lena asked, watching as Glowvine methodically solved the simple maze they had constructed in its chamber, navigating a glowing nutrient orb through a series of barriers using carefully controlled tendrils. Sin shook her head in wonder. "That's the most fascinating aspect. It's not just stimulus response. There's problem-solving, memory, perhaps even something like consciousness. The growth patterns in what we've identified as its central neural structure are becoming increasingly complex. It's learning," Lena said softly. "Every day, it learns more about its environment, about us." The light pattern communication system has expanded to include over 40 distinct signals now, and Glowvine initiates communication as often as I do. What neither scientist mentioned aloud was the implication of this development. They were no longer simply studying an unusual specimen. They were establishing contact with a new form of intelligent life. 3 months after Glowvine's arrival on Biosphere 4, the relationship between the plant and its caretakers had evolved into something resembling symbiosis. Lena had established a routine that included regular pruning sessions, now understood to be essential for Glowvine's healthy development, and feeding schedules that provided the plant with a variety of energy sources, from nutrient solutions to small, decommissioned electronic devices that it consumed with evident pleasure. In return, Glowvine produced specialized enzymes that proved valuable for various station operations, from breaking down waste materials to synthesizing complex proteins for the medical bay. Its ability to rapidly process certain toxic compounds also made it an effective emergency filter for environmental contaminants, a capability that had been tested twice more in minor incidents. Most significantly, the communication system had developed into a rudimentary language. Using combinations of light patterns, simple physical movements, and even electrical impulses that BIOS could detect and interpret, Glowvine had begun to express increasingly complex concepts, preferences for certain conditions, requests for specific nutrients, observations about changes in its environment. "It asked about outside today," Lena reported excitedly during one research meeting. "At least, that's my interpretation. It produced the patterns for beyond and while orienting itself toward the external viewport. It's curious about its original habitat," Dr. Sun suggested. "I think so. I showed it some footage from the jungle canopy where we found it, and the response was intense, accelerated light patterns, rapid tendril movement, almost like excitement." Security Chief Morales, who still insisted on attending all research briefings concerning Glowvine, frowned deeply. "I hope you're not suggesting what I think you're suggesting, Petrova." Lena met his gaze steadily. "I believe controlled exposure to its natural environment could yield valuable research insights. A brief, supervised expedition." "Absolutely not," Morales cut in. "That thing stays in containment. We've been lucky so far, but luck runs out. The moment that plant senses freedom, who knows what it might do." Chief Morales is right, Director Kwon said before Lena could argue further. "The risks outweigh the potential benefits. Continue your research within the established parameters, Dr. Petrova." Lena acquiesced outwardly, but the idea had taken root in her mind. Glovine's development appeared to be reaching a plateau within the confines of the containment chamber. For truly groundbreaking insights into its nature and capabilities, field observation might eventually become necessary. For now, though, she focused on refining their communication system and learning everything she could about Glovine's unique biology. The plant continued to thrive under her care, its growth now carefully managed through regular pruning to maintain a size appropriate for the enhanced containment chamber. What no one aboard Biosphere 4 anticipated was how their careful management of Glovine had fundamentally altered its evolutionary trajectory. The regular pruning, the controlled environment, the consistent nutrition, all of these factors had selected for specific traits within the organism's highly adaptive genetic structure. The Glovine that now pulsed with bioluminescent light in Lena's laboratory was becoming something new, something that had never existed in the wild jungles of Xylos. It was becoming domesticated. The crisis that proved this transformation came 6 months after Glovine's arrival on the station. A catastrophic power surge, caused by an unexpected solar flare from one of Xylos' twin suns, temporarily disabled several critical systems throughout Biosphere 4. Emergency protocols activated immediately, but the damage was extensive. In the chaos of the station-wide emergency, Lena rushed to her laboratory, concerned about the impact on Glovine's containment systems. To her horror, she found that the power surge had completely disabled the environmental controls for the specimen chamber. The backup systems were struggling to maintain basic life support, but the specialized conditions Glovine required were deteriorating rapidly. "BIOS, what's the status of power restoration to Laboratory Section C?" she demanded, checking the manual readouts on the containment chamber. "Power restoration estimated in 4.7 hours, the AI responded, its voice noticeably strained as it operated on reduced capacity. "Critical systems are being prioritized." Lena looked at the chamber in dismay. The temperature was rising, humidity falling, and the carefully calibrated light spectrum was reduced to basic emergency illumination. Glovine was already showing signs of distress, its bioluminescence flickering erratically, tendrils withdrawing toward the central mass in a defensive posture. "It won't survive these conditions for 4 hours," she muttered. A desperate plan formed in her mind, one that violated every containment protocol, but might be the only way to save the specimen they had spent months studying. With a deep breath, she activated her personal communication device. "Director Kwan, this is Dr. Petrova. The power surge has compromised specimen 7G's life support systems. Request emergency authorization to relocate the specimen temporarily." "Relocate where exactly?" came Kwan's harried response. "The entire station is operating on emergency power." "The Botanical Conservatory in Sector 9, Lena replied. "It has independent environmental systems and could support 7G's basic needs until power is restored to the lab." There was a pause before Kwan answered. "That's a public area, Petrova. Containment would be minimal at best." "I understand the risks," Lena said firmly, "but I believe they're outweighed by what we stand to lose if the specimen dies. 7G has proven its value to this station multiple times now." Another pause, longer this time. Finally, temporary authorization granted, but with conditions. Security escort at all times. The conservatory is to be sealed to all non-essential personnel, and at the first sign of problematic behavior, termination protocols will be implemented. Is that clear? Perfectly clear, Director. Thank you. The transfer was a tense affair. Glovine, already weakened by the deteriorating conditions, had to be carefully removed from its primary containment and placed in a mobile transport unit with only basic life support capabilities. Lena spoke soothingly. Throughout the process, using their established light pattern language to communicate what was happening and why. "It's okay," she murmured as she guided the transport unit through the station corridors, flanked by security officers. "This is temporary. We're taking you somewhere safe until your home can be fixed." The Botanical Conservatory was one of Biosphere 4's few concessions to aesthetics over pure functionality. A large, domed chamber filled with carefully curated plant species from both Earth and compatible exoplanets. Designed as a psychological comfort for the station's long-term residents, it provided a small oasis of nature amid the sterile efficiency of the research facility. Now, cordoned off by security barriers and emptied of its usual visitors, it would serve as Glowvine's temporary sanctuary. Lena selected a secluded corner of the conservatory, near a cluster of blue-leaved ferns from Proxima Centauri b that would help shield Glowvine from direct view. With careful precision, she transferred the plant from its transport container to a prepared bed of nutrient-rich soil. She had brought essential supplements and a portable light array to help replicate the specimen's preferred conditions as closely as possible. "There you go," she said softly as Glowvine's tendrils slowly unfurled, exploring its new environment. "It's not perfect, but it's better than what we left. Just rest now. Recover your strength." For the first hour, Glowvine remained subdued, its movements minimal, bioluminescence dimmed to a faint glow. Lena monitored its vital signs anxiously, concerned that the transfer might have caused more stress than anticipated. But gradually, the plant began to show signs of recovery. The bioluminescent pattern stabilized, pulsing in the slow, steady rhythm that indicated contentment. Tendrils extended cautiously, exploring the nearby soil and even gently investigating the Proxima Centauri ferns. "It's working," Lena reported to Director Quan via comlink. "Vital signs are stabilizing. I think it's going to be okay." "Good," Quan replied tersely. "Engineering reports progress on power restoration. You should be able to return your specimen to proper containment within 3 hours." As the hours passed, Lena noticed something remarkable. Glowvine wasn't merely recovering, it was thriving in this new environment. Its bioluminescence had taken on a vibrant quality she had never observed before, and its movements seemed more fluid, more graceful somehow. Most strikingly, it appeared to be establishing a relationship with the surrounding plants. Tendrils would extend to gently touch a leaf or frond, then withdraw, followed by subtle changes in the light patterns. "Bios, are you recording this?" Lena asked, fascinated. "Affirmative, Dr. Petrova. I am detecting unusual electromagnetic patterns between specimen 7G and the conservatory flora. Analysis suggests a form of information exchange. It's communicating with them," Lena whispered in awe, "or at least attempting to." By the time the power was fully restored to the laboratory sections, Lena was reluctant to remove Glowvine from the conservatory. The plant was displaying such remarkable behaviors in this more natural setting that separating it from this environmental enrichment seemed almost cruel. "Director Quan," she began carefully when reporting the plant's status, "I'd like to propose a modification to our research protocols. The specimen's response to the conservatory environment has been extremely positive. I believe we could learn much more by maintaining it in this setting, with appropriate security measures, of course. You want to leave a potentially dangerous alien life form in a public area of my station." Quan's tone made his opinion of this idea abundantly clear. "The conservatory would remain restricted," Lena argued. "And look at the data, Director. There's no sign of aggressive behavior. If anything, Glowvine seems calmer, more balanced in this environment. The interaction with other plant life appears to be fulfilling a vital social need we didn't even know existed." After considerable debate and a series of compromises, a new arrangement was established. A section of the conservatory was permanently cordoned off and enhanced with security measures, creating a semi-natural habitat for Glowvine that still maintained necessary containment. The plant would remain under constant surveillance, but it would have access to a more complex, stimulating environment than the sterile laboratory chamber could provide. The results exceeded even Lena's optimistic expectations. Within this enriched environment, Glowvine's development accelerated in fascinating ways. Its communication abilities expanded dramatically, incorporating new patterns and signals inspired by its interactions with the conservatory plants. Its growth became more intentional, more artistic almost, forming elegant spirals and symmetrical patterns rather and the somewhat chaotic expansion observed in a laboratory. Most significantly, its relationship with the human researchers evolved. Glowvine began to display what could only be described as social behaviors, orienting itself toward visitors, producing welcoming light patterns when Lena or Dr. Sun entered its section, even seeming to perform by creating complex bioluminescent displays when it had an audience. It's not just intelligent, Lena reported during one research presentation, it's social, perhaps even empathetic. It responds differently to different individuals, recognizing them and adapting its behavior accordingly. Security Chief Morales, who had reluctantly accepted the new arrangement when no security incidents occurred, remained skeptical. It's learning how to manipulate us more effectively, he muttered. But even Morales had to admit that Glowvine showed no signs of the predatory behavior that had initially alarmed them. It accepted its regular feedings of decommissioned electronics and specialized nutrient solutions, showed no interest in expanding beyond its designated area, and seemed genuinely content with the routine of care established by the research team. The pruning sessions, once approached with caution, had evolved into something almost ceremonial. Lena would signal her intent using their established communication system, and Glowvine would prepare itself, extending the growth that needed trimming and withdrawing other tendrils from the area. After each session, it would produce a distinctive light pattern that the team had come to interpret as gratitude or pleasure. It's like taking your pet for a grooming session, Dr. Sun observed with amusement. It knows it's going to feel better afterward. Lena smiled at the comparison, but shook her head. It's not quite like that. There's an intelligence here that goes beyond what we attribute to animals. It understands concepts, abstractions. It asks questions. 1 year after Glowvine's discovery in the jungles of Xylos, Biosphere 4 held a small, somewhat tongue-in-cheek anniversary celebration for what had become the station's most unusual resident. Even Security Chief Morales attended, though he insisted it was only to maintain proper protocols. Director Quan raised a toast to what he called the most surprising research success in the station's history. Dr. Sun presented data showing how Glowvine's enzymes and biochemical compounds had revolutionized several areas of the station's research. And Lena, who had become so attuned to the plant's communication that she sometimes found herself thinking in light patterns, shared footage of Glowvine's latest achievement. Using its tendrils to manipulate simple tools, a behavior never before documented in plant-based life forms. As the celebration concluded, Lena remained behind in the conservatory, sitting quietly near Glowvine's habitat. The plant pulsed with gentle light, extending a tendril toward her in what had become a familiar greeting gesture. 1 year, she said softly. We've learned so much about you, but there's still so much we don't understand. What you are, how you think, what you want. Glowvine's response was a complex cascade of light that rippled from its central mass outward. A pattern Lena had come to associate with deep communication, the plant's attempt to express complex thoughts beyond their shared vocabulary. I know, she smiled. We're still learning how to talk to each other, but we're getting better at it every day. The plant shifted its tendrils, creating a new configuration that framed its bioluminescent core in an almost deliberate display. The lights pulsed in a pattern that Lena recognized, their signal for mutual benefit, for symbiosis. Yes, she agreed. That's what we've created, isn't it? A partnership. You help us understand life beyond Earth, beyond our limited definitions of plant and animal, intelligent and instinctive. And we help you grow, learn, become something new. As if in confirmation, Glowvine's lights brightened momentarily before settling back into the steady rhythm that indicated contentment, the pattern of a being at peace with its place in the universe, however unusual that place might be. In her research journal that evening, Lena made a final entry for the day. Specimen 7G continues to defy classification. Not fully plant, not animal, perhaps not even a natural species as we understand the term. What Glowvine represents is something more profound, a reminder that life finds its path, adapts, evolves, communicates. Sometimes it hunts robots and corrodes metal. Sometimes it saves space stations and creates beautiful light displays. And sometimes, like the temperamental orchids of Earth that thrive only with precise care, it just needs regular pruning, the right nutrients, and maybe a little conversation to become something extraordinary. In the conservatory, Glowvine pulsed with light as the night cycle began, its tendrils gently swaying in patterns that might have been a form of dreaming. Around it, the other plants of the conservatory grew a little taller, a little stronger, influenced by the subtle electromagnetic fields generated by their unusual neighbor. And throughout Biosphere 4, the crew went about their duties, no longer questioning the presence of the intelligent plant predator in their midst, just as humans on Earth had once stopped questioning the wisdom of allowing wolves to evolve into dogs or wild grasses into wheat. Life, as Lena often reminded her colleagues, finds a way, not just to survive, but to connect, to communicate, to create relationships that transform both parties. Even when one of those parties happens to be a carnivorous, bioluminescent vine that just needs regular pruning and the occasional electronic snack.